Hello, welcome. Episode number 9 of the tutorial on linear programming. In this episode, we want to take a question that involves word problem that we have to generate the inequalities before we can plot on a graph. So under linear programming, the first episode, we had a discussion that the linear programming just deal with many solutions, or how we can solve a certain solutions, whereby the mathematical model contains series of inequalities, and in that inequality has some feasible solutions we can get, and getting the best solutions give us the optimal solutions that we are looking for. So in this case, in transcribing inequality from a linear programming questions, we have two key steps we should follow. One step is to identify the constraints that are in the question. So in these constraints, we identify them by variable. So we use the same commodities or quantities mentioned in the question to represent one variable. So we say we are using X. So any commodity or quantities that are similar will all bear the symbol X. Then another ones will also bear Y. Don't forget, we are dealing with inequalities involving two variables. So these variables will represent the similar commodities, or better still quantities, that are mentioned in the question. Then the second criteria is that we are going to have some natural inequalities, which is going to be the first one greater or equal to 0, then the second one also greater or equal to 0. In a sense that the problem you want to solve will not involve negative numbers. So we'll be using these as natural inequalities for every linear programming question. So let's take the first question. We are having a carpenter can make at most 30 tables and at most 20 tables and 30 chairs per day. That is what he can make at most. Then each table represents 3 hours of labor, and each chair also represents 2 hours of labor. So the maximum total of hours of labor that the carpenter has at his disposal is 96. So the first question, we have to give 3 inequalities that express the conditions above. 3 inequalities, excluding this. This is also part of it, but this is not in the question. Then we have to graph and shade the common regions that satisfy the inequalities. Then finally find the maximum number of chairs and tables that he can make within the time at his disposal. So in this case, we need to identify the 2 commodities or 2 quantities which are similar being mentioned. And you can see that a carpenter can make at most 30 tables. We can see also table being mentioned here. We are also asked to find the tables. So you can see table is similar. So we are going to use one variable to represent that. Then we can also see that it's making chairs. So chairs also become another quantity. So here we are just going to represent them by X and Y, as chairs for X, table for Y. So here we are going to say that let X and Y represent. The first one is chairs, right? I think the first one was table. So we are picking the X and Y to represent the tables and chairs respectively. So this is representing what? Tables. And this represents what? Chairs. But from the question, if you check, we can see that we are having, we can make at most 30 of the chairs, at most, meaning that the highest it can make will be 30, which means it can make up to 30 or less than 30. Simply put, it can make less than or equal to 30. So in this case, we can write the inequality. We can say that if x represents chairs with a table, it means x is less or equals to 20. Then that gives us the first equation. Then for that of y will also be less or equals to 30 as what? Equation 2. If you check carefully, we are having at most 30 chairs, at most 20 tables. So the table and chairs have their representation either up to 30 or 20 or less than that, respectively. So this is what we are going to get. This is the first equation or the first inequality, the second inequality. So now let's think of the third inequality, since the question asks us for 3 inequalities. Now we are having 3 hours of labor for what? Table making. You spend 3 hours. So 3 hours of the x and the 2 hours of the chairs will give us a total hour of 96. So we are going to have that inequality also. So the hours of labor, we are going to have 3 of the hours for table. So 3 hours plus 2 hours. He can also work up to 96 hours. You say he has 96 hours at his disposal. So he can either work up to 96 or less than 96. So we have less or equals to 96. So these are the 3 inequalities that we can generate from the question. But we also have a natural inequalities. Our natural inequalities is going to be x is going to be greater or equal to 0 and y will be greater or equal to 0, because we can't have a negative number of tables or negative number of chairs. So these become the total, the inequalities we are going to have. So from our previous discussion we've done under linear programming involving inequalities, we said that after we have our inequalities, we convert them into an equation so that we find the intercept on the x and the y axis. So converting the inequalities into an equation. So from here we are going to have our x should be equals to 20. Then here we have our y equals to 30. In the case of this, it becomes 3x plus 2y equals to 96. Then the final one is going to be x equals to 0 in the case of this, y equals to 0 in the case of this. So now we've converted them into equations. Then now we can find the intercept on both the x and the y axis. In the case of this, it's going to be the origin. So 0 on the x-axis, 0 on the y-axis. Here, 0, both in that direction. Now, if we take this one, it means we are going to just locate 20 and draw a line through it. 20 on the x-axis, 0 on the y-axis. Similarly here, when you take this, 30 on the y-axis, 0 on the x. So a line through 30 parallel to the x-axis. So let's pick this as the only point we can solve. So for 3x 2y equals to 96, when x is given as 0, then 2 will divide the 96 to give us y. So y is going to be 2 dividing this, that will be 48, right? So therefore, our point is going to be 0 and 48. That's what I'm going to plot on the graph. Then, when y also is 0, what will be the value of x? 0. 3 will be dividing, so that will be 32. So therefore, 32 on the x-axis, 0 on the y-axis. So now we are going to plot 1, 2, 3, 4, 5, 6 on the graph in order to find the values of the tables and the chairs. So now let's put the point in there. Let's start with this x-axis 0, y-axis 48. So 0 here, then 48. So 45, so we have 48 somewhere here. Then 32 on the x-axis 0. So 32 in here. So we draw a line through that. So that's the first one, which has the equation to be 3x plus 2y equals to 96. Then we are going to locate this 20 on the x-axis, 0 on the y-axis. So 20. Then we draw a line through that parallel to the y-axis. So this is our 20. So that will be x equals to 20. Then here, y equals 30. So let's see a line through 30 on the y-axis, parallel to the x-axis. So that also gives us y equals to 30. The next one is going to be x equals to 0. So we locate 0, then we draw a line through it. So you mean the y-axis. Y equals to 0. So here we draw a line parallel to this, which is the same as this. It means the two axes are part of our inequality polygon. So now we can see the regions to shade is going to be here, having all the lines forming side of the polygon. So if you check carefully, you can see that all the lines are forming side of the polygon. This line is x equals to 0 is there. This line is y equals to 0. This line x equals to 30. This line y equals to x equals to 20 and y equals 30. So this is the polygon. The question is asking for us to shade that region. So the region we are shading is this. So if you check from the question, we are to graph and shade the common region that satisfies the inequality. So the common region that satisfies the inequality is going to be this region we are seeing here. I believe you get it. Good. So now let's deal with how we can find the maximum. If you can remember from our previous lesson how we find the maximum, we locate the vertices of the polygon drawn from the graph and slot it into a given equation. Here we're not giving any given equation, so we slot it into x plus y. It's a maximum. If I add x plus y, the maximum value is what you're looking for. So let's pick the vertex. Let's start from the origin. This is one corner. So we have 0, 0. On the x-axis 0, y-axis 0. If you add the 2, you still get 0. Let's climb up a bit. 0 on the x-axis, 30 on the y-axis. So we have 0, 30, 0, 30. If you add the 2, you get 30. Let's come up a bit. So we are going to have on the x-axis 12, on the y-axis 30. So 12, 30, 12, 30. That will give us 42, right? We are moving down to this place. Here we can see 20 on the x-axis. Somewhere, I think it's below this. So we can have 20. Then we have 18. And if we have 20, 18, that will give us 38. So now the last point is going to be this corner, which is already 20 on the x-axis, then 0 on the y-axis. So we have 20, 0. If you add them, you will get this. So now we are looking for the maximum. And what is the maximum? The maximum is going to be 42. But we are not going to state 42. It's a maximum number of chairs and tables that can be made in that 96 hours. So we can see that here 12 is standing in for x. And x is what? Table, right? Y is going to be chairs. So it means the carpenter will be able to make 12 tables and 30 chairs within the 96 hours of labor. So even though here we did not specify the maximum number, the maximum number of value is helping us find the number of the commodities that can be made individually. So 12 for tables, 30 for chairs. I believe this video is a bit long, but you took your time and followed from the beginning to where we are. So under linear programming, we can also solve questions in this nature. If you like this tutorial, share with somebody, subscribe, comment, and let's get interactive. Bye-bye.